So today we are going to take a second example on simultaneous equation. On the board here we have x squared plus y squared equals 65, which is a quadratic equation, and x plus 2y equals to 3, which is a linear equation. So I'll call x squared plus y squared equals to 65 equation 1. X plus 2y equals to 3, my equation 2. I now make x the subject of the formula. So I have x equals 3 minus 2y. I call that equation 3. From here, I now substitute equation 3 into equation 1. So wherever I find x, I put in 3 minus 2y. So I have the 3 minus 2y raised to power 2 plus y squared equals 65. So I now expand. 3 minus 2y into 3 minus 2y plus y squared equals to 65. So I expand. 3 times 3, that's going to give me 9. 3 times minus 2y, that gives me minus 6y. Minus 2y times 3 gives me minus 6y. And minus y times minus y gives me plus 4y squared. Then plus 4y squared plus 4y squared equals 65. So from here, we are now going to correct line change. So I have the 9 minus 12y plus 8y squared equals to 65. So from here, I can equate this to 0. I now say 9 minus 12y plus 8y squared minus 65 equals to 0. I simplify that further. I can now say 8y squared and minus 12y, 9 minus 65, that's going to give us minus 56 equals to 0. This now becomes a quadratic equation. So from here, what is common? When you look at this, you find that 4 is common. 4 goes into 8y squared and 2 times. So I have 2y squared minus 3y squared minus 14 equals to 0. So from here, this is a harder factorization. But so what to do? You pick 2, the coefficient of y squared, multiply with a constant 10, which is minus 14, that gives you minus 28. You now think, what do you do to manipulate this so that when you add or subtract, you have this to be the coefficient of y to be minus 3. So what do? I know that 2y squared plus 4y minus 7y minus 14 equals to 0 is the same thing as 4 times minus 7, that gives me minus 28. So I've got that. By the time I multiply this and this again, and then when I do this, I've got that. So what I now do, I have got the factors so that I can now manipulate it and get my minus 3y. So from here, what is common? 2y is common. 2y is common. 2y in the 2y squared, I have the y. 2y into 4y, I have the 2. What is common here? You find that minus 7 is common. Minus 7 into minus 7y, I have the y. Minus 7 to minus 14, I have the plus 2 is equals to 0. So from here, I group them. So I have a 2y minus 7 into y plus 2 equals to 0. These are the factors of the quadratic equation. Now from here, I can now solve each of them. So I pick 2y minus 7 equals to 0, Then 2y, 2y equals to 7. I divide both sides by 2. I have a 2y divided by 2 because I want to eliminate 2 equals to 7 over 2. This will cancel, this will cancel. Y equals to 7 over 2. Now I also have my other factors. So I have here y plus 2 equals to 0, then y equals to minus 2. So the values of y are simply 7 over 2 and minus 2. So now I'm going to look for the values of x. I now substitute the values of y into equation 2. So what's my equation 2? I have here x plus y equals to 3. So in the first case, I have y to be 7 over 2. So I bring in the 7 over 2. So I have the x plus 2 into 7 over 2 equals to 3. So from here, 2 go, 2 go. And the x plus 7 equals to 3. When this crosses over, I now have the x equals to 3 minus 7. X equals to minus 4. I also consider when y equals to 2, when y equals to minus 2. So I have here x plus 2y equals to 3. And what's my y? My y is minus 2. I have the x plus 2 into minus 2 equals to 3. So I have the x plus 2 times minus 2. That's going to be minus 4 equals to 3. From here, I solve for x. When this crosses over, I have this as x equals to 3 plus 4. Then x equals to 7. So I'm through with this equation, and we can prove them by picking the values of x and y in each cases into any of the equations to satisfy the simultaneous equation. Thank you very much.